Hello, this is Gojko, and today I'm going to be talking about designing good test cases. The talk is called Given When Then with Style, but it's not really about Given When Then as a format. I know this is a robot framework conference, and I wanted to give you something that would be applicable to robot framework and actually any tool that you want to use for automating test cases. So we're going to look at what I think are 5 really important rules, how to save a ton of time maintaining, writing, executing, and defining test cases. Um, I used to work a lot as a consultant helping teams do this. For the last couple of years, I've mostly been working on my own product. That's Narakeet. Narakeet helps people create videos easily. One of the things it does is it helps developers convert Markdown into video. So, for example, you can have a Markdown defined like this, where you extract some video frames, you add some text-to-speech narration, and then you kind of make a video from that. The reason why I'm mentioning this is that I'm the only person working on this. I'm the product manager, the pre-sales person, the sales guy, the post-sales support, developer, software support, and tester. And in order to make this work on my own, the tool has about 2.5 million users a month now. I need to be very effective maintaining and defining software tests. So this has gotten me kind of to think about the purpose of what I'm doing quite a lot, because I can't afford to waste time on ineffective test cases. At the same time, I need a ton of test cases so I can do all of this on my own. And it's gotten me to think about what are some universal rules that I can apply to help me do this. And that's kind of what I want to talk about. So I will use Given When Then as a format for describing what we are going to do today and how we're going to kind of use it, but that's more because I'm familiar with this format and I'm not that familiar with Robot Framework, unfortunately. But I said, we're going to look at some rules that are universally applicable. And I think kind of quite importantly, I don't really see a big difference between something that's described like this with keywords given when then and executes in Cucumber or SpecFlow or something like that, and something that looks like this. That's kind of more kind of robot frameworky or fitnessy or something like that, that can then look at some keywords, execute keywords. For me, Given When Then is basically a pattern of defining test cases. Given some hand value, when the dealer takes an action, then the action is like this. And there's not a lot of difference between kind of a gherkin file or something like this. And at the end of the day, there's not a lot of difference between something like this and something like this. That's kind of a visual test case. This is a way that I'm describing test cases for a different product I was working on called Mind Map, where there's a lot of complexity in visual look and feel. And we had to have a huge test coverage for visual look and feel because that's what was the selling point. So we had, like, given some precondition, given we're setting a label like this, when we kind of render the two nodes, then it's going to look like this. So Given When Then is a way of just describing test cases. This is nice documentation it renders in Markdown, but it's also a fully automated test I can execute, and I can then say, well, this is what I expected to happen, this is what actually happened, this is the difference. You know, is this a bug, is this not a bug? We can look at this thing from many different perspectives. And it's quite an effective way of designing test cases. So Given When Then is a way of kind of thinking about testing more than a way of kind of specifying things in Gherkin. And Given When Then is a way of describing test cases that at least kind of my understanding is the first occurrence of this was with a tool called JBehave in 2006, when Dan North and Liz Keogh were talking about getting business users to engage better with developers and testers around defining good business-oriented test cases. And they wanted to get people to stop thinking about all the kind of technical stuff around it. Just think about what are the business scenarios there. But given when then, if you go a few years back in history from there, you look at Gerard Mezarosh's book on effective X-unit testing patterns, he talks about something very similar. He just calls it differently. He says to define effective unit tests, you need to have arrange, act, and assert. And kind of what that means is prepare all the preconditions, then act on them, and then kind of look at all the assertions. Don't mix them up. If you mix them up, things are really, really difficult to understand. You go a bit back in history. Well, there's kind of Alistair Cockburn writing about effective use cases. He talks about a precondition, a trigger, and a post-condition. And we can go back, and I'm sure that if we went all the way back to ancient Egypt, we'd find some kind of way of describing this thing with hieroglyphs. I actually kind of tried to figure out how given when then would translate into hieroglyphs using a Google tool called Fabricus, and it says, well, you know, you get something and then you get something and you get something else. And what I really like is kind of there's this guy thinking about it at the end. And I think that's a really, really important piece of the whole puzzle. Like if we describe things with given when then well, then we are able to think about this in a much, much better way. And that's kind of what I want to get you to start maybe thinking about. One of the things that's really important about designing good test cases, it doesn't really matter what tool we use, or whether they're manual or whether they're automated, is figuring out what relates to what and are we doing the right thing. And for that, I really love given when then as a phrase because it gives us the sequence. For me, the most important aspect of given when then is actually the sequence of these three concepts. It's arrange, act, assert. It's precondition, trigger, postcondition. Is what do we describe first, what do we describe next, and how do we make it very, very clear what's going on. If we don't respect that, then we get a mess like this. We get, oh, I click here, 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 and then I do this, and then when I do this, and then I do this. This is not given when then. It's a different type of information pattern. It's mixing preconditions and postconditions. It's mixing steps. It's mixing evaluation. It's a very easy way to automate what was previously a manual test, but it's not a necessarily good way of conveying the information. So the way I think about given when then is mostly as a documentation pattern. It's not a language for automating things, because automation is easy once we have something that makes sense to automate. For me, the key thing here is really the sequence, and the purpose of splitting given when then or arrange, act, assert or precondition, trigger, postcondition is to clearly separate inputs and outputs so we can reason about them. So I can say, well, I see that the result here is 10%, but why? Like, what brings me to 10%? Is it like the fact that the user is logged on, so we give them 10%? Is it the fact that Mike is logged on, maybe Mike has something special about him? Is it that we've bought this thing, or does that give me 10%? Or is it, why is it like that? So once we kind of clearly separate inputs and outputs, we can reason about them, and people continuously keep using these tools to program in plain text. Please, please, please don't. Yes, it's possible to do that, and yes, these tools make it easy to program in plain text, but there's lots and lots of programming languages that are better than English or Polish or Finnish or something else. Programming languages are really good for describing automation. Let's not try to kind of automate stuff in English. And what we can start thinking about is once we separate out preconditions and triggers and postconditions and clear up what's going on, we're probably going to divide a big mess of things into 5 or 6 things that are much, much clearer, much more to the purpose, much better defined. And then we can actually start reasoning about them. I can say, well, these are the preconditions, this is the trigger, this is the postcondition. Does this make sense? Can I discuss this with a business user? Can I show it to somebody and talk about, well, is this even correct? Why is it like this? What's going on here? And this kind of brings me to the next step. I think clearing up given when then as a sequence is really, really good as a first step in clarifying test cases or refactoring test cases, because it helps us then start reasoning about, well, should this even be here or not? Do I need to have this, or is this just noise? And one of the things that's really interesting to think about is, why are we describing kind of given the user mic logs on? Is this important for the process of testing, or is this important for the purpose of executing a test? All these tools, Robot Framework, Cucumber, Fitness, Concordion, they all kind of have a similar way of architecting things. And they allow us to describe some automation that talks to the system under test, and they allow us to describe some kind of human readable thing that talks to the automation. Now, this line over here is very easy. This kind of almost nobody has a problem defining the line between the system under test and the testing framework around that system, because we know what's production code, what's testing code. But defining the line on the top, figuring out what should go into the top level description, what should go into the automation, is a lot more difficult. Like, should a user mic logs on be here or here? And how do we describe it, and where do we describe it? Now, what's interesting about this stuff is that thinking about what should go where is also a question of, well, how do we maintain these things, and how do we understand these things easily in the future? And I think both are very, very tightly connected, both of these questions. And one kind of heuristic I like to use, it's not always correct, but it's a really good starting point, is to think about, is mic logging on important just for the purpose of the test? Or is it important just for the process of executing a test? Like in a case of a discount, does the discount depend on mic logging on, or is it just a way of getting to kind of that screen? And then kind of thinking about putting kind of what's important for the purpose of the test in the top level thing, and putting how we get there, things that are important for the choreography of a test, into the automation layer. The reason why these two things are important, and splitting them is important, is that they're likely to change at different times. What we are testing is going to change when the business logic changes. How we are testing is going to change depending on where we inject the testing framework, depending on the design of the application. So we can decide, well, you know, for this specific test, we do need to go through the user interface. So we're going to click, 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 click here. Or for this specific test, well, we can narrow it down to a business component that's maybe a Java class or a .NET class or some microservice, and that's going to affect the how. Also, if we change the design of the application not to require a person to log on before we go to the shopping cart, then the logic of calculating the discount doesn't change, but how we kind of get there might change. And splitting out what and how is really, really important, because they will change at different times. Splitting out what and how is also important because it lets us reuse automation for many, 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 many test cases. So that, say, when we change session management, we don't have to go through 700 test cases and update them, we change them in one place. At the same time, it allows us to actually kind of focus on, well, I'm changing my design from synchronous to asynchronous. Well, I'll just update it here. I have the business logic test to prove that I've not broken any business logic. Or we are kind of adding new business functionality, we can reuse the automation layer. So dividing what and how becomes really, really important for maintaining these test cases, but what and how are not the only pieces of information we need. What I think is really, really important is, once we kind of specify what and automate how and figure that out, documenting the why. Understanding things so we can come back to them 6 months later and say, well, you know, this thing is no longer 10, it's now 12. Why was it 10? How do we understand, is the code right or is the test case right? How do we understand if the test case is obsolete? And I think that's very, very important. It's also very important to be able to kind of show these things and discuss them with the team, discuss them with other people. So kind of document the why, explain the purpose, and then kind of divide what and how. In this case, let's assume that the purpose of this is that we want to apply volume-based discounts to encourage people to buy more. And it's all about the number of tickets they buy, not the kind of total price. And then when they kind of buy 2 tickets, the discount is 10%. This lets us actually have a good discussion with business users. Like, do we really care just about the number of tickets? What if I buy 10 very cheap tickets? Should that qualify for a discount, or should we actually go for a price? Like, if I buy 2 expensive tickets, or if I buy a single expensive ticket, should we give people a discount? What do we really want to encourage? What's the business model here? Documenting the why helps us discuss these things and understand them in a more kind of systematic way. Also, this then helps us figure out, is this thing the right thing to do? And it helps us review these things far into the future. One of the interesting things to think about is, at what point does an automated test bring value? And I think from my experience, an automated test brings value in exactly 2 cases. It brings value the first time it passes. If we did not have the discount calculation, we add this discount calculation, we kind of get this thing to pass, I know that it's going the right direction. I know I can kind of maybe show this to a user to get some feedback, or we can start adding more cases. But after that, this test passing doesn't really give me useful information. The next time this test brings value is when it fails. Think about this. Imagine you have 700 test cases like this in your testing system, and then you run them and they pass. You don't do really anything. You run them again, they pass, you don't do anything. You run them again, they pass, you don't do anything. You run them again, 6 months later, this thing fails. Now, that's when you jump. You look at this and say, the system is telling me now the discount is 15%. Should this be 15% or 2% or 10%, or how much should it be? Maybe we have a bug, maybe we have a misunderstood requirement, maybe we changed something over here and that had an impact on this and we didn't understand it has an impact on this. So a failing test provides value. So the next really important thing to think about when we're describing these things is to understand that the value is a lot more frequently going to be about discussing failures and understanding failures than it is going to be necessarily kind of understanding it the first time around. So my third rule for designing good test cases is to make it really easy to understand what went wrong when it goes wrong. Did the infrastructure explode? So we just need to rerun the test case. Was there an unexpected impact that we kind of didn't think about, so we need to go back to the business users? Or do we just have a bug? And how easy is it to understand the bug? So by focusing on understanding failures, we make it easy when we have like thousands of these things to quickly navigate to and pinpoint what do we need to fix, rather than going through and fixing stupid stuff that doesn't necessarily need fixing. I mentioned that kind of this product I'm working on is helping people build videos, and there's a lot of testing stuff I need to do around that, and videos are not necessarily deterministic. Video encoding is lossy by definition, and kind of comparing bits and bytes might not even give me what I want. What I want is are people kind of what they see, is this going to be good or not? And I use a lot of test cases like this, where I would have a scenario saying, well, if you paint a slide, if you paint some text on top of a video, what does that look like? I'll generate the video and then I'll divide it into keyframes, I'll render an image, and I'll compare it to a previously expected image in this case. So when we do something like this, the key thing to understand is, if something goes wrong, how easy is it to spot the diff? And I've really optimized kind of these things to look at the stuff like, okay, in this case, I can see that the different thing is kind of on every frame, I have a tiny different line there. Is that line because of the rendering of the slide on top of the video, or is that line because of the infrastructure, or is that line because of a font or something? So this is an example where I've actually caught myself doing something very stupid. I've changed a font on the system and it broke a bunch of tests. And instead of kind of trying to figure out how do I fix the tests? I've realized, well, Gojko, you're stupid, you changed the font, it had kind of a negligible impact, but it had, broke some tests. I just reverted the font, changed it, passed, and it's all okay. It helped me figure out what kind of stuff I need to do and was this important or not. So optimizing the diff, optimizing how we look at the failures and understanding the failures quickly is really, really important. So kind of, here's a couple of ways of how we can make it easy to understand failures. What's really important is to make sure that each output can be explained with inputs, that we have the right inputs there, that we have the right outputs, and that's why given when then again is a really interesting first step because it helps us separate these things. Once we can kind of figure out is the output explained by the input, then we can kind of make sure that the action is clear. Are we kind of testing one thing? Are we testing many different things? And then kind of really removing everything else. Kind of looking at this stuff, like I have a timestamp I really don't need here. And it was my mistake for putting stuff like that into the test case. It's an output that doesn't need to be there. Can just remove it and make the test case a lot more resilient. So kind of going back to the example of kind of the bonus discount I started looking at, well, how do we know if given a user puts 2 tickets in, the user gets a 10% discount? Why is it a 10%? Where does the 10% come from? We're missing some information. We cannot explain this output with inputs. So that means we've kind of removed too much in the cleanup. And I think kind of we can start looking at, well, how do I explain this? I can add an input saying, well, given some discounts are configured, well, the minimum, if you put 2 is 10%, if you put 5 is 15, if you put 10 it's 20, then I can explain this output. And we start getting into kind of describe the why, figure out, that it's going to help us understand whether the example is correct. Once we have the example, can we explain the output with the inputs? Are we missing something? Do we have too much? Do we have inputs that don't need to be here? Like I've mixed, removed mic and things like that. And now we can look at, well, executing this. Where do I execute it? Do I actually need to execute it through the user interface? And then the automation layer can do click, 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 click. Do I need to execute it by sending an API call to the discount engine? Do I need to execute it by bringing 5 databases, 3 microservices, and something like that, and doing that? And we can then, on a test by case basis, decide where this thing needs to go. Now, we're better than we were before. We're kind of getting into a situation where this is almost good. But most people stop here, and I think now we have a really nice opportunity to make sure that we have a good test case, because this is a rubbish test case. It looks sensible, you can kind of syntax parse it, but it's not really testing anything important, or it's not really proving anything important. One of the key things that kind of I've realized looking at this, working as a consultant, is kind of really everybody's going to agree on a happy day scenario. Testing a happy day scenario like this is, yes, it might give you some good feedback, but it might mislead you into thinking that you finished the job and there's a million other things missing. So one of the kind of really, really important things a good test case needs to do is cover the edge cases, cover the boundaries, because that's where people's understanding falls apart. Instead of just thinking about what are the positive things we can do, we need to look at where do these values change? Where do we move from 10% to 15%? Are we doing it the right way? Is 5 is a discount boundary? Does that mean equal or less than 5, or does that mean equal and greater than 5, or does that mean exactly equal to 5? Because lots of different people coming from different backgrounds will have different understanding of this. And especially if you work with a larger team, the more people you have, the better the chance for misunderstanding. I've mentioned that this is really not about a specific testing tool, and you can apply this to many different types of test cases. And just to demonstrate this, I'm going to use a visual example. Wireframes, what people often don't understand, are just examples. Like given when then, like any kind of keywords you can have in robot framework or something like that. And if you start thinking about wireframes as examples, lots of other interesting opportunities open up. You know, a designer might say, I want it to look like this. And then we can say, okay, that's a happy day scenario. What variables do we have here? We have like the starting and the ending airport, and we have the price, and we have the time of the flight. Well, what are the edge cases? What are the boundaries? What if there's a connecting flight? Well, okay, if there's a connecting flight, you can add kind of another kind of item there. What if I connect 10 times? What if I connect 15 times? What if there's not enough space on the screen for that? How do I show that? How do I, how many times can I connect? Well, here we also have a boundary like, okay, these are all on the same date. What if I go to New Zealand? I will start on one date, I will land on another. How do I show that? We have here a price that fits neatly on the screen. What if I'm doing something in Polish zloty or Icelandic kroner and it can go very big? Do I reduce the font? Do I show K for thousands? What do I do? I mean, there's lots of these interesting questions that can come out of this that are all the boundaries of this thing, and they're all important to document to make sure that we have shared understanding, to make sure that we don't have to go back and redo every time somebody develops something. One of the really interesting things about testing and defining test cases is that it helps us provide feedback. It helps us play around with this stuff faster than developing a software system. Yes, we can go through all these test cases by developing a software system, showing it to people, getting them to play with it, and then they can complain. Or we can get them to complain on a wireframe or a piece of textual information. I think from my perspective, one of the most important lessons I've learned working as a consultant is that it's very, very difficult for people to tell you what they want up front, but they can very easily complain. So offer them stuff to complain about, and test cases are very often concrete enough so we can complain. So instead of just thinking about one positive scenario where kind of we have, that's enough, that's 10, we really need to kind of dig in deep and start looking at edge cases. Do we go to kind of 11 tickets? What happens? Is it always 11? Is it less than 10? Where do values change? How many things do we need to do to document all of these boundaries? And then what's really interesting is that if we have too many boundaries, we probably have a design issue. If you have something that has so many boundaries, it's difficult to describe as a test case. That probably means it's going to be really, really messy to describe in code. It's going to be really messy to evaluate from a business perspective, and we're missing some design or domain concept there that we need to go back. We need probably to add another level of abstraction. We need to redesign the system a bit and explore it. I think that's another kind of reason why focusing on boundaries is so important. It gives us feedback on our understanding about the domain. Ultimately, kind of once we start doing this, we can start looking at, well, how do we capture this information in a way that is easy for people to comment on and understand and think about things, which brings me to kind of the final really important rule that I wanted to talk about is making these things easy to use. And one of the kind of most important aspects of making these things easy to use for me is to structure it in a way that business people, developers, testers can consume easily, can understand easily, can discuss and collaborate on. And this means that we need to give people the edge cases. The edge cases are where the understanding breaks down. The edge cases are where we will have all these kind of learning and discussions and a ton of other things. The edge cases are important to document, but the edge cases are really difficult to grasp. You can't just throw difficult edge cases at people and expect that they'll get it immediately. So in order to get the edge cases easy to understand and easy to work with, we need to provide people with a good structure to understand this stuff. And a good structure is what given when then is about. It's letting people separate out the preconditions from post conditions. It's splitting out the what and how. It's focusing on the important things. And at the end of the day, when we have a good structure, we can then help people lead in and understand what's going on easier by showing them some usual examples. Happy day scenarios, in this case, have a place because they help us understand the context. So the way I like to kind of think about structuring good test cases, the way I like to help think about structuring multiple scenarios, complex features is, well, first, provide people with a couple of usual examples, things that are always or never, things that will be easy to understand, that help somebody think about the problem a bit and prepare them for understanding all the complex, difficult edge cases, prepare them for understanding all the kind of complexity that's going to come later. And usual examples will help you also define a good structure. They will help you understand what are the important inputs, what are the important outputs, what is the relationship between these things. Once we have a good structure, we can then look at defining edge cases and exploring edge cases by thinking about this thing. Well, this is a number. What are edge cases for numbers? Edge cases for numbers are, well, negative, around 0, very big, very small. If we have, say, dates, what are the edge cases for dates? Well, we have a date in the past, a date in the future. We have a non-working day, maybe leap year, leap day, leap second. We can have strings. Well, if this is a string, we can look at Unicode, we can look at string length, we can look at empty string, we can look at strings with only spaces and things like that. And it helps kind of drive all these edge cases that sometimes you don't want to keep them, sometimes they're going to point out to some really important knowledge. And structuring these things then that are easy to understand becomes important. And here we go back to kind of this start case that I started refactoring. We have a description on the top that says, well, the title of this is bulk purchases. And we have some paragraph describing that. Why is that important? We want to incentivize people. We want to kind of figure out what's going on. And then we can have multiple types of bulk purchases, describe the scenarios. For example, one volume discount scenario, again, for ticket sales, volume discounts, we can explain why. We can then have some kind of global setup of this that's unique to a whole set of examples. And then we can have, like, given this boundary, then it's this, given this boundary, it's that. And we can start with kind of simpler things and go into more complicated things. This applies to both examples within a group and then kind of more complicated scenarios where maybe we have a mix of different types of discounts that are interacting with each other. Like if I have a volume-based discount and a price-based discount, which one wins? Do we take the largest discount or the smallest discount? And we can combine these things into something that's easy to understand. So kind of doing these things is important because we get something that is both the documentation and a test case. Doing these things is important because it helps us maintain these things easier. If I want to change how my discount limits work, all I have to do is update this. I don't have to go and update all the automation. If I want to add another level, I can just add a few more examples here and kind of run these things without going and updating 700 test cases. At the same time, if I change some kind of design of the application thing, if I move from buttons to labels, if I move from clicking to tapping or scrolling or something like that, I don't have to update this. I can update it in the automation layer. 6 months later, if one of these things fails, I can easily understand what's going on. I can kind of see the case that failed. I can see whether it failed because things have changed across everything, therefore the infrastructure is wrong, or things have changed only in one case, therefore we are kind of not calculating it correctly. And I can then go and kind of discuss potential fixes with my colleagues and with my business users. So kind of to start summarizing this, I think there's kind of 5 important things to remember about designing good test cases that apply to pretty much any tool that you might want to use, and any type of test that's automated that you might want to use. These things don't apply to manual exploratory tests, but designing a unit test, designing a technical integration test, designing something that you're going to put in robot framework or Cucumber or fitness, really kind of, there's not much difference from a testing design perspective. One is that given when then is a useful information pattern. It's a useful way of describing the preconditions, the trigger, and the post conditions of a use case, of a unit test, or of an acceptance test. And the reason why it's important is it helps us see the critical bits. It helps us reason and discuss about the critical bits so that then we can talk about, well, which of these things should actually go into the automation layer? Which of these things should actually stay in the top level documentation layer? And do we understand why the outcome in this case is like that? Can we explain each output with the inputs? Are we missing any inputs? Do we understand where things are? So then we can document the why. What I mean by documenting the why is almost all these tools have some way of putting plain text there that's not going to be automated. You can put some headings, you can put descriptions, you can put some kind of textual freeform thing, and these things are really, really good to capture the purpose of what we're going to do. Then we kind of specify what we're doing and automate the how. Next, we need to structure these things so that if they fail in the future, they're easy to kind of dissect, they're easy to understand. That means that we need to figure out that we have all the right preconditions in place. We kind of focus on one thing to test so that we can understand one thing that went wrong. We have a clear relationship between inputs and outputs. We have a good way of describing the diff. We have a good way of showing just the part that failed and zeroing in on that, so we can optimize for human involvement. We can optimize for your time when a failure happens and the time of your business users, rather than understanding 700 kind of broken test cases that are all over the place. And once we have that, that's kind of a really good structure to start thinking about, do we have the right test coverage? Please, please, please don't stop at the happy day scenarios. Don't stop at kind of the sunny cases. When you give business users, oh, you know, what do you want? They'll always describe the expected stuff. Testers are always going to focus too much on kind of the negative stuff. Bringing it all together is important because a misunderstanding happens around the boundaries. Understanding where all the boundaries are, understanding what kind of boundaries we're thinking about, and getting that in place is important. Making sure that we have the same expectations around these boundaries is important, documenting that, and at the end of the day, automating that becomes important. A good business edge case is a good test case, and we want to keep running these things in the future. And then finally, to make sure that things are easy to use, we want to help people understand those documents easily, get gradually into the thematics. So get some usual examples, happy day scenarios, always, never cases, to help people understand the problem space without getting too lost in the edge cases. Then make sure that there is a good structure of this, where we have a table where we have kind of given and then we are kind of, the relationship is clear. And when we have a good structure, we can look at, well, what inputs does this structure expose? Are they numbers? Are they dates? Are they strings? Are they a combination of things? And then we can get testers to apply testing heuristics to come up with really good edge cases, to define those, to capture those, and make sure we have a shared understanding across the whole spectrum of these edge cases. So remember the acronym USE: usual cases, structure, edge cases. That's pretty much it. Thank you very much for your time, and hopefully we are going to have a good discussion session now after this.